Hi everyone. I am not at school today. Along with a couple of other Wells math teachers, we have two presentations um, at a teachers event. So we are kind of teaching other teachers and how we teach in our classes. So we'll only be back to Wells about 3 o'clock, 3:30, or maybe even 4, depending on the traffic. But if you can stick around after school, I can help you out. If not, you can come tomorrow during free blocks or tomorrow after school. I can help you out too. Or if you're not available tomorrow, just bring questions to class on Friday and I'll help you out. Okay? So in this video, I'm just gonna cover. So right now for this block for this class, you are supposed to work on this 10.2, 10-2 exercise, and you can find total of 16 questions, right? And it is basically 4 different types, and each type repeated 4 times. Okay, so it's not too bad. They're all pretty similar, right? They're all pretty similar. So let me go over them with you. All right, so here is the first type, which is question number 1 to question number 4. All right, so make sure you take notes while you are watching the video, not on the steps that I'm carrying out, more on the concept behind it. All right. Okay, so here we go. So the function g is defined as piecewise. Piecewise meaning we have it's not just one piece. We have 2 pieces or 3 pieces. It depends. Right now, seems like we have 2 pieces. And if your x value is less than -2, if your x value is less than -2, we are gonna use this -x² minus 3x minus 1 as your g of x. Now, if your x value is greater than -2, if your x value is greater than -2, then the g of x is that. So the equation, your g of x, the equation of your g of x changes depending on what is your x value. So another way to see this is, okay, let's say this is -2. If my x value is that side, then I'm gonna use this. Okay, if my x value is this side, then I'm gonna use that. Okay, so depending on the x value, your equation of g of x changes. All right, now this chapter is about finding limit, right? Finding limit. In other words, we are trying to find if your x approaches a value, what is your function going to approach to? Right? As x approaches a value, what is your y going to approach to? Right? That's what we mean by finding limits. And previously, we know that in order for limit to exist, we must come from the left and come from the right, and they must meet at a point, at a common point, then the limit exists. Okay, so we learned about this concept earlier on in 10-1 in the previous exercise. So none of this should be new right now. All right, so let's try to solve this question. Let's do part A first. So here we are trying to push my x so my x is approaching -2 plus, which means something like a number. My x value is gonna get close to a value that is a little bit more than -2. So maybe something like -1.999. Right? Maybe something like that. This is just an example. Of course, you can add more nines after it, and then you can find something that is even closer to -2, yet a bit bigger. Okay? So if your x gets close to this, so we're going from, is it left to right or right to left? I hope your answer is right to left. So let's say this is -2. I'm coming from here because my -1.99999 is somewhere there, maybe. Right? This is my -1.99999. So I'm coming from right to left. x value is going to be greater than -2 or less than -2. This is a little bit more than -2. So we're talking about this. So my x value is greater than -2 because it is something like -1.99999, which is greater than -2. So my g of x in this case is going to be x plus 4. So this is the same thing as saying limit x approaches -2 with a small plus, and then my g of x is now x plus 4. So as your x gets very close to -2, what's this going to become? It should be, what do you think that's going to look like? So you can feel free to put this in your graphing calculator, but this is simply a straight line, correct? This is simply a straight line where your y-intercept is 4, so this is 4, and your slope is 1, right? So when your x is -2, so your x is -2, this is going to be -4. When your x is very close to -2, what is your y going to be? It should be 2. In other words, we can kind of just substitute this value in there. Does that make sense? Okay, so that's how we can evaluate the value. Alright. Now, but what I'm saying here is I'm not telling you guys to just straight go ahead and substitute the x value in there. Substitute this -2 in there. That's not what I'm asking. What I'm asking you guys is, as you get close to -2, if your x goes close to -2, what is your y going to get close to? It is also going to get close to 2, right? So this is not, technically, this should not be the value when we substitute this in here. It can't be, because we're talking about limit. It is a number where as your x approaches this value, -2 plus, your y will approach 2, which can be seen from the graph. As you get closer to -2, then your y is getting closer to 2. Okay? But a technique, a quick way of finding what this is without maybe the sketch, without using the graphing calculator, is to substitute the -2 in there. So that value is the limit. Alright, now let's look at part B. So for part B, we have limit x approaching -2 minus. So something like -2.000001, something like that. Of course, you can find other values that are smaller than this, but what this is saying, the -2 minus, that means a value that is a little bit less than -2. Right? So this could be it. Now, if it's a little bit less than -2, then what is my equation going to be? Is it the first one or is it the second one? Remember that the equation depends on the x value. If your x value is something that is less than -2, which is what we have here, then the g of x is going to be that. So let me rewrite this. This will be limit x approaching -2 minus, which means a little bit less, a little bit smaller than -2. My equation is now the first one. I recommend you guys to always put the parentheses there, just to be sure, just to be safe. -1, and that. So you have two choices right now. You can put this in your graphing calculator, right? In fact, I'm just going to do that right now. Okay, I'm going to bring up Desmos, and you can see the graph of this. All right, so I have put down the equation negative x squared minus 3x minus 1. I put that in Desmos. Negative x squared minus 3x minus 1. Yep. And here is the graph. Now, we are interested in when my x approaches a value that is a little bit less than -2. So, in other words, we're going to the right. approaching from left to right. Right, so let's look at the graph. My negative 2 is here. So let me just put on the point. Negative 2. Actually, you know what? Let's not worry about it. Okay, so my x is going to get closer and closer to negative 2, but it's coming from the left. What happens to my y value? As I get closer and closer to it, so if I zoom in, get closer and closer and closer and closer to it, what happens to my y value? My y value becomes very close to what? What number? It's going to get close to negative. It's going to get close to 1. Does that make sense? So I'm going to get close from left to right, and then as my x gets closer to negative 2, my y value, you can see that it is now 0.995. If I bring it a little bit closer, so now my x is negative 2.001, my y value is 0.999. So as I get closer, my limit, my y value, will get closer to 1. Okay? So the fast way, again, the fast way to find this out is to simply substitute the negative 2 in my x. So you can put that in your calculator. Make sure you have a parenthesis around the negative 2. So if you do negative 2 squared minus 3 times negative 2 minus 1, you should get 1. But again, I cannot say this enough. This only helps us to evaluate it, but conceptually, we're talking about what happens when I get closer as my x approaches negative 2 from the left hand side. As my x approaches negative 2 from the left hand side, my y approaches 1. Right, so that's what limit is about. Limit means approaching. What are you approaching? Okay, so my part A, my limit, my y is approaching 2. For part B, my y value approaches 1. Since coming from the right and coming from the left, they don't necessarily go towards the same number. For part C, your answer for part C is going to be undefined. The limit does not exist. Okay? So, hope you guys get the idea of the whole shebang behind the scene. The only thing that you have to be careful with this piecewise function is to know when do you use the right equation, right? And then that's not too hard if you understand what does this little plus, this little minus. If you understand what that means, then it shouldn't be too difficult for you to choose which equation to use as your g of x. Okay? I encourage you guys to put your equation in Desmos and try to see visually what happens when your x approaches some certain value, and how does that affect your y. What is the y value? What's the value that your y is approaching? Right? Because ultimately that's what limit is about. But a quick technique to evaluate the values is to substitute them in there. But we need to know concept-wise, they don't mean the same thing. Alright, I think that's what I have for you guys for now. Go ahead and try out the exercises. So you guys should be able to do number 1 to number 4. Help each other out, and I'll see you guys in the next video.